wisdom, student enrollment. That's what the class of God students enrolling. Supreme wisdom, I study it hard. The study of myself is the study of God. Supreme wisdom, write your letter, get your X. Supreme wisdom, that's what you'll be getting next. Supreme wisdom, some call it the lessons, but I call it life, actual facts, no guessing.
So you remember I said, pay attention to the video, because I'm going to ask you a few questions, right? My first question is, did you understand what the video was saying? Be honest.
Not completely.
Not completely. That's good. But that means that you're learning, right? And if you've never heard something before, the first time you hear it, you're not just going to get it. You're going to get it some of it. And you only got the part, you know, that you can relate to.
Yeah.
The other part, you're going to have to, you know, revisit it, learn it, then incorporate it. So that's what I wanted you to say. Actually, I didn't want to say I get it, because if I say I get it, it's going to make me skip this whole part that I want to do. So I like it when you say I don't get it, because that makes me jump in and make me look good. Give me something. Okay, so what I have here is, okay, you found out where it came from. Thank you. So in that short video, it showed us really how to use Punnett square. But what we use that Punnett square to do is predict the probability that you will inherit a certain trait from your parents, right? It's just that's what it's about. It's about being able. It's for probability. I don't want the camera to be okay, because I'm trying to get them to see. Okay. So what it's saying is that for each trait, we're going to say, oversimplifying, for each characteristic there is about you, you get one from your mother and one from your father. Okay? But that trait is going to be the exact same thing. So, say for instance, again, let's say the shape of your hands or something like that. There's a specific part on your DNA or your chromosome that's going to tell you, you know, what that is. But you're going to have the same one. So I watched the video earlier, and it said like this. We're going to say this is your chromosome. And so if I take this and separate it, right, each part of this represents a different part of you. And you get one from your father and one from your mother. So this is your father and this is your mother, right? And so this part of the chromosome for each is going to give us our hand shape, right? This is the hand shape from your mother, and this is the hand shape from your father, right? And then you're going to inherit, you're going to get that, you're going to get the code for that from both of your parents. But the thing about it is that what is being expressed is only going to be from one of your parents. So even though you're going to get both of them from your parents, you're only going to be able to see one of them. And so how do we predict that one that you're going to see, or what's going to be expressed in the parent's offspring, is by using the Punnett square. The Punnett square is simply a chart for mapping probability. It's not exact science. It's not going to tell you that you will get it, but it's saying the probability of the offspring of these two people to get that, okay? And so we're going to, you know, so if you get two traits, or two alleles as they call them, that's the part of the chromosome that actually deals with that one trait. If you get two alleles from both your parents, that means that you have two for one physical trait, right? But your parents also have two for one physical trait, because they have the same makeup as you. So just like you have to have two, both your parents have two as well. Yes, ma'am.
So you have one that is expressed and one that's hiding.
Yes.
Similar to the, yes.
Yes. So what they do, yes, sir.
I had a question. So let's say, for example, and this may be something for later, but let's say, for example, when you're talking about, in this case, pigmentation. So
I'm talking about handshake.
I'm
talking about handshake. getting ahead of yourself. You going where I want to go. That's why I wanted to stick on handshake,
Okay,
because
okay.
that didn't have to do with grafting process. But yes, it applies. Skin pigment, you know, the color of your skin is something that you get from your parents, right? You know that how dark you are, you don't get that from where you live, right?
Right.
Because if Brother Daryl was born in Russia, he still would be a brown-skinned brother. You get it? Because at some point, one of his parents carried, at least one of his parents carried the gene for the color of his skin. Now, he might, on a regular basis, because it's cold and dark there, he might not, you know, be as dark as he can be, said as he would tan, but the overall color of his skin comes from what he got from his parents, not from where he lived. Now, there would be certain climates that would be advantageous to his skin color, right? Because for darker skinned people, they need more sun, right? And for lighter skinned people, they don't need as much. And so living in Russia might not be the best place for him, but that's just where he was born, and his skin color is his skin color because his parents. Okay? You want to say something else?
Well, the question I had was dealing with you saying you're going to get, and only one is going to be expressed.
Mm-hmm.
So let's say, for example, like I got an uncle who has like this pink white.
Mm-hmm.
She's not really white, she's like pink. So, but the children came out like in between. Nobody is exactly her color. Nobody is exactly his color. So, and then of course you might have, say for example, somebody's nose, who's a combination of two different noses in one.
Right.
See what I'm saying?
Right. And see, like I said, the way that I explained it is an oversimplification, because what makes your nose shape is not only determined by one thing. This part of your nose might be determined by a different gene than this part of your nose, and the tip of your nose might be a whole different one of these. This part might be nose tip, this might be nose ridge, right?
Right.
This might be a nostril shape. And so those are all different, very different traits. So each little part of you has its own trait, its own code. And so it could seem as if we blend, you know, and come up with something in between, but it has to do with that word they use was genotype and phenotype, okay? And so I'm just gonna say G is for genotype. So when you're dealing with genotype, the genotype is what is on the inside. So we're just gonna say genotype is what is on the inside. And phenotype is what is on the outside. We're gonna say P is phenotype, and we're gonna say this is the outside. And so with genotype and phenotype, going back to this question you had about the skin color of the children, and it seems like it's a blend between the parents, but the thing about it is that even though she might have looked pink on the outside, inside of her DNA, there was a coding for the skin type that you saw in the children.
Right.
Okay? So even though what was expressed in the pink relative, she might have had brown inside of her DNA, but it didn't get a chance to be expressed.
From her mother or her grandmother coming down?
From the mix between her parents, how when they both came up, one might have been dominant over the other,
Right.
but just because one is dominant over the other doesn't mean it's not there. It's there, but it's hidden.
Right.
Yes, ma'am.
Well, in human beings, they don't have something called codominance. Like in flowers, where you can mix a red flower and a white flower and get pink. You don't have that codominance where you mix, you know, like you're saying.
I see what you're saying, but you see, you deal with pigment. See, the thing about it is that
Let me say this. If you did, it would come down, you know, you would like, you have and have.
that's not codominance. You have, no, there is codominance. You have codominance and you have incomplete dominance.
Yes, yes,
So you have just regular old dominant recessive. You have two traits, even though they're different, they both can be just as dominant. You know, and there's another one when they can be just as dominant to the point that they literally, you just have two different colors. So if you ever saw, like, you see with us, with human beings for the most part, with one color through and through, right? We're gonna have one tone through our whole body. You know, different parts of our bodies might be tan from the clothes we're wearing, but for the most part, it's the same tone. But say, for instance, with a zebra. Zebra is very striking. It has black, some people say black stripes on white fur, black fur with white stripes, however you want to see it, but there's two different colors that are expressed, some over here, some over there. And it's this right here that is in control of those colors, the pattern that they make, why they only appear on their back and not on their belly. All that is written on your genes, okay? And the different, you see what I'm saying? Why is the skin on the palm of your hand the same as the skin on your face? This determines that, okay? But going back to this, you have genotype and you have phenotype. So the genotype is the genetic makeup of a person, and in your genotype and phenotype, you have two traits that you get from both parents. So in this case, we're dealing with hand size. So the common practice when you're dealing with a Punnett square is you're going to take one letter, and then you're going to have that letter express the dominant trait and the recessive trait. And so for the dominant trait, you're going to express it as a capital letter, and the recessive trait, you're going to express it as a lowercase letter. So since we're dealing with hand shape, right, we're just going to say H. So we're going to say, or hand size, something like that. Hand size. So what we're going to say is that for you, you have, well, for me, I have big hands, right? So I'm going to say this is my genetic, I'm going to hypothesize that this is what my genotype is, just for the sake of this. Let's say that this is one I got from my mother, and this one I got from my father. So this is from my mother, and this is from my father. So this gene is only dealing with my hand size. This represents big hands, this represents small hands. My mother gave, I got a gene for big hands from my mother, and I got a gene from small hands from my father. But yet, when you look at me, on the outside I have big hands, even though I have the gene for big hands and small hands. And when you ask why I did, so if I have both Y's in my hand in the middle, it's because on Mendel's laws of inheritance, genetic inheritance, he says whenever you have two genes in play, the one that's going to be expressed is the dominant one. So in this case, big hands are dominant. So my genotype is big hands, small hands, but my phenotype, I'm just going to say so what's on the inside is big hands and small hands, but what you see on the outside is big hands. Okay? So even though there's two things that's inside of me, what you see is the stronger one, which is big hands. Big hands are stronger than the small hands, right? So in this case, even though I have both on the inside of me, all you see is the big hands, because the big hands won in the battle. Okay? But say for instance, I had big hands from my mother and big hands from my father. My genotype, what you can't see is big hands, but still in the same essence, you still see me with big hands, right? But now, say if I have small hands, I inherited small hands from my mother, and I inherited small hands from my father. My genotype would be two small h's, and then finally, my phenotype of what you see on the outside is small hands. But the only way I would be able to express on the outside what you see is small hands. The only way that can happen is if I inherited a small hand from my mother and a small hand from my father. Then since they're both recessive, I'm just going to have small hands. But as long as there's a dominant allele or a dominant gene in play for that one trait, you're only going to see what's dominant.
Supreme wisdom, some call it the lessons, but I call it life, actual facts, no guessing.